Hello, this is Rahul. In this lecture, I am going to cover a protocol which is TCP, which comes under the layers, transport layer. Then what are the services provided by TCP? First one is a process-to-process communication. What process-to-process communication? There we have two devices, and in one device, suppose one process which is Firefox is running, another device Chrome is running. If these two devices want to communications, in that case what happens, then we have to establish a connection, and the connection name is a TCP. And with the help of these connections, the TCP defines the rules how they communicate. These two processes will communicate to each other, right? And second one is stream delivery services. What stream delivery means, about the information which is transferred from sender to receiver, which go in form of byte streams. Each bytes have some numbers, right? These two processes which are in PC1 or PC2, they send information to each other in form of byte stream. Suppose what we do, how do we establish TCP connection? We do three steps. First one is a connection establishment. How connection establish happen? First, sender, there is a two persons, and sender will first request to the receiver, right? Their request has came. Now the receiver will return back the acknowledgement. What this tool, these two transmissions will tell us the connection established. If these two communication happen, what which means connection established. And after connection establishment, data transfer will take place, right? You can see where data transfer, and we have some sequence number for each byte or each segments. Now after being data is transferred, and that the client will initiate the terminations with the sender, with the receiver. So in last step is terminations. Now we'll see how we actually these process communicate. Suppose we can assume these two process TCP connection actually will create a virtual pipe between these two process first, and these are the numbers we can put, and these are the number of which were associated with each bytes. You can see here, this is how tunnel being created by TCP connections. Now we'll see how we do these numberings. You can see these are the numbers, and what is the range of numbers we use. Suppose if in TCP connections, each byte have been represented with numbers. You can see the number range fall between 2 or 32, right? 32 minus 1. Any numbers which we can start with any random numbers between these two ranges. Suppose we have started by 1000, second byte was numbered with 1001, 1002, so on, right? Second one is a sequence number. Sequence number is for what we use for segment. Segment 1, segment 2, segment 3, and each segment have same number of bytes. Suppose each segment have, for here we have taken 3 bytes. So size of each segment is 3 bytes. You can see over here each segment has 3 bytes, right? Now the sequence number, similarly as we can start from any numbers for which is falling between these two numbers 0 to 2032, because for sequence number we use 32 bits size of sequence number. So any numbers which is less than this number to about 32, we can select the starting number of segment. Now this number represent the point the first byte of the segment. Similarly in this number for second segments, we can see here this represent the second byte, and this is the third one, fourth one, and fifth one. Now if we want to find out the byte number for this one, we can find out with the help of this one numbers. We can add 1 plus 2, 20,000 plus 2, then the byte numbers of this one we can get very easily. Now similarly, suppose if you send any packets, we get acknowledgement, then acknowledgement must have been numbered. So you can see here sequence numbers 2000, if we send, then we get 2001. What it means, 2001 means say receiver is expecting 2001 packet or 2001 segment. Like these are the segment numbers. Suppose if we want the receiver has, you have sent this segment, and then receiver will expect 2001 or 2003 segments, like that, right? These are the how we numbered, and later we'll see in detail how these connections is established. Now first, before going to how the connection been established, we need to know how the what the packet what we keep inside the segments. Segment add actually the packet as transport layers, we call the segment, and the TCP connections actually assume the data or packets which are transferred as a segment, right? Suppose we have a data which are being transferred. So it has two parts. Segment has two parts. Every packet has two parts. First one is the data and second one is a header, right? Header what a header contains? Header contains the controls how the data will be transferred throughout the network. Headers keep the information how the data will be transferred throughout the networks to reach the final device destinations, right? Then we need to know how what the informations we keep in header, so that the data will be transferred smoothly and very easily. So the size of header, as we see in each packet, 20 to 60 bytes. Similarly, data size will calculate, because of total size of this segment is 65,535. You always remember bytes, this is in bytes, right? Now what is the first 16 bits of header? We have 16 bit of header for port number. This similarly next 16 bit we use for destination port number. Similarly, for sequence number, next 16 bits, so 32 bits we for sequence number, and acknowledgement number also we use for 32 bits. This is very important H length. So as we have computed for in IP datagrams, there we got a field which was named with H length. It has 4 bits, but how do we actually get the 20 bytes to 60 bytes number? Because H length represent the size of header. So suppose if we have 20 bytes, which is the minimum one, and from this number, so we can make from this number 4 bits numbers, we can make up to 15 numbers. So suppose if we have a number like 5, suppose we have number 5, which was computed from H length. H length numbers for by 4 bits, what it would be 101. I think this one is correct, 10. Now we will multiply this number with 4. Always we will multiply with 4 any numbers which is represented by H length. Suppose H length is 6, in that case number would be 6 to 24. If H length is 7, then 4 number would become 28, right? This is how, but this number will not change. This number will not change, right? You always keep 4 bytes, because we use 32 bits words. So that is the reason we always multiply with 4, right? Now we have some bit in reserved. These are these are for future use. Now these are the very important things you can always been asked in exams. You have 6 bit flags. So for first one is urgent, and acknowledgement, post and reset, and synchronization finish. These are the what this means. Urgent is very important one. If urgent flag is high, what it means, then this segments contains whole segments will contain the urgent data. Urgent data, I will tell you what the urgent data we have. And as acknowledgement is what? Acknowledgement is if the segment contains the acknowledgement. Suppose we are sending in one segment, right? And share, and then server will return the acknowledgement. If any segments is containing acknowledgement data, then in that case we will keep this flag high. And posing, we will see how when we use post flags and reset synchronizations. The first communication what we make from client to receivers, for that case we will use sync to high. The first when we establish the TCP connection, in that case we client send first synchronization segments. So in that case we will make this sync flag high. Finish command is what? When we need to terminations, we need to terminate the connection. In that case we use this fin flags in the segments to high. Next 16 bits for Windows ISP, right? Checksum, as you know, for error detections and urgent pointers. When we use urgent pointers, suppose this flag is high. In that case, urgent pointers will point out the last byte of the data, last byte of urgent data which is present in data sections. We will see later all those things in detail, but this padding field you always keep in mind. This size would become 40, up to 40 bytes. These are all the things I have explained. One more things, window size we represent here in TCP connection in byte. You always remember, window size always be in bytes unit, right? This see window size is what? Sequence of segments. Window size contains sequence of segments S1, S2, S3. Suppose each byte, each segment has size of 60 byte. If you take, then I will multiply 60 into 10, 60 into 4, I will get 24 bytes. This is what window size of this window size, right? Now how do we actually, let's go in detail how we establish a connections. First one is a connection established, we will, and then data transfer and data termination. As we have seen TCP connection, how it means established. First we will look in detail connection establishment. And in connection establishment, it is a three-way handshakes. For how it happens actually, let's see it. Suppose a client make a request with the segment name. You always remember we use sync sy and flag high, right? If any flag, any segment which is containing this field value 1, what it means, this segment is a first segment which is for connection initiation. Connection initial connections being established. Now after getting this sync segment, then the server will send back the sync and acknowledgement. What it means, it is replied of segment command with acknowledgement, means yes, and it will also advertise the window size. We'll see later why what is the use of this window size, all those things. Now after the connection is established, then it send clients will send back the acknowledgement. Note that in these two segments there are sequence number, but in this segment there is no sequence number. You always remember, you can see sequence field is there is also a sequence field, there is no sequence field. What it means, only this segment is what known as ACK segment. This segment is synchronization ACK. This segment is synchronization, right? Now these are all things I told you. One more thing, suppose if we send synchronization segment to the server, what happen if we send continuous 1000 2000 synchronization segment to the servers? For each synchronization request, server will allocate the resources to the connection. So for each TCP server allocate resources. So it servers must have limited resources. Then what hacker does actually, hacker will create the packets which these are the packet or segments which will have in header different IP address, right, different IP address. And what happens in this SYN segments, different IP address, then the server will understand all these packet synchronization segments which are coming have are coming from different locations or different persons. So then the server is will start the resource allocation for each synchronization segment, right, all those things. Now solution to this problem is server may use cookies kind of strategies and may verify the clients. We don't have other than this options. Now now we'll see the data transfer, right. After establishment of connections with client start sending data. If there is a normal data, there is no problems. Once we have urgent data or any data which is very important one, suppose if we use a flag which is PSH flag set to high, in that case what happens, as we know, in receiver side and sender side there is window size which we can call in other word buffer, read write buffer. If we send any data to the receiver will keep in buffer, and then after we getting whole sequence or whole sequence of packet or whole sequence of that window size, whatever the buffer is full, then after it data are transferred to the applications, which suppose Chrome is expecting data from this buffer. After this whole window is filled up, then the segments are transferred to the application layer. So if in the segment which is set with PSH comma PS flag to 1, what it means, it will escape the buffer. So segment which has set with PSH command, it will skip this buffer, will not go and directly it will transfer to the application layer. Why, when we, it is important when we talking with the audio, if we are transferring audio and communicating say live or talking with some receivers via phone, or if there is a video streaming, in that case this kind of PSH flags will become one, right. I hope this is clear. Here we are bypassing this buffer and directly sending to the application layer. I hope this is clear. Now this is very important word, urgent data. If there is a URJ pointer, how do we identify any segments is containing the urgent data? We will simply keep urgent flag to high. If we set urgent flag to high, in that case what happens, then we have another field which is called urgent pointer, which will have how many in segment what we have seen, how many bits we have for urgent pointer. You can see here 16 bit we have, right. 16 bits we have, 16 bits. How, what are the maximum byte maximum numbers we can possible, 2 power 16 minus 1. This number is possible by using 16 bits. So this pointer will point the last byte of data section of urgent data. This is urgent data, you can see this is urgent data. This urgent pointer will point the last byte of the urgent data, right. I hope this is clear. Why and why it is important, why it gives the whole information, because always urgent data we keep from the beginning of data section. If we know the urgent data start from 0, then if any pointer which is pointing last one, then we can find out very easily urgent data. So that is the reason that with the help of these two things we can find out the urgent data from the segment very easily. And this urgent data is very important one. Why? Suppose if there are me as a person who is the downloading file from any server, suppose Google servers, I am downloading a video file which is of 2 GB, right? And later on what I'm thinking in between, it takes almost 2 minutes or 60 minutes, right? In between, I don't want to download the file. In that case, what happens, I may disconnect. Simply there is a cancel button, I will cancel. When I cancel the downloading, what happens, there is a segment which is being transferred from client to the servers, which this urgent flag 1, and it will find out what kind of data. If there is a interruption or cancel of downloading, in that case the receiver will understand this is the interruption, and sender doesn't want to download this file, and then receiver will stop sending the file to the sender, right? Hope this is clear. Now in last case, what happened, last step is the connection termination. In connection termination, what happens, client will send the fin, a segment with a fin flag set to high, and that case fin and SEK been responded by the server to the senders. Later on, SEK which was sent by sender to the, this is very simple one, and this thing may be asked. And when we say the half close means we stop sending, but may still receiving data from the server or from the receiver, right? In that case, we may say that half close, right? Thank you.